Hello dear students, welcome to my channel. Today, from today onwards, we are starting a new subject. It is called Power System 2. It is part of the uh, Electrical Engineering curriculum of 6th semester GTU, which is Gujarat Technological University. And if you are looking forward to make your career in power system domain, then this subject is very useful to you. So, uh, this subject consists of total 9 chapters in which we will be discussing different aspects of power system, and we will be uh, visiting them. We will be observing them up close. We will be learning a lot from that. And today onwards, we are going to start the first chapter, which will discuss about the basic principle. It's just there's not so much new things in this chapter. Only the things which we are already aware of, or which we have previously learned from previous subjects or previous courseworks. But uh, this subject, sorry, not this subject. This chapter is only just to brush up some things, just to remind us, take us back in the power system domain, if we have not revised things from a long time. Okay, so the first chapter itself is called basic principles, which discusses about the basics of power system. Okay, so power system में जो कुछ भी ऑपरेशन होता है, it takes whatever operation which takes place in power system, the all the operation will be either take place either in three phase system or the single phase system. Okay, अब थ्री फेज सिस्टम जो होता है which is used for better handling of bulk power. Okay, जितने bulk power applications होते हैं उसके अंदर what do we do, use थ्री फेज application. Okay, एंड सिमिलरली जो स्मॉल पावर कैपेसिटी एप्लीकेशंस होते हैं, ठीक है, जैसे कि लाइटिंग का लोड हो गया, डोमेस्टिक लोड हो गया, ठीक है, तो ये सारे लोड को कंज्यूम करने के लिए वी यूज सिंगल फेज पावर और सिंगल फेज सिस्टम्स. ओके, एंड जो पावर हम लोग जो यूज़ करते हैं, जो डोमेस्टिक साइड पे हम लोग जो यूज़ करते हैं, और रादर आई शुड से लुकिंग एट लार्जर पिक्चर, जो हम लोग डिस्ट्रीब्यूशन साइड पे जो पावर हम लोग यूज़ करते हैं, दैट पावर वी रिसीव फ्रॉम ग्रिड इन द थ्री फेज फोर वायर सिस्टम ओनली. ओके, वी ऑलवेज यूज थ्री फेज फोर वायर सिस्टम, जिसमें तीन जो होते हैं वो आपके मेन फेज होते हैं, और चौथा जो होता है दैट इज न्यूट्रल. ओके, so we have three phases R, Y and B, and then there is neutral. Okay, here in this figure you can see आपको दिखेगा तीन फेज R, Y, B and then there is a neutral. अब when you will see that जो नीचे वाला जो फिगर है उसमें आप देखोगे तो ये जो तीनों फेज और न्यूट्रल, it is where is it coming from? It is coming from the secondary distribution transformer. Okay, सो ये सप्लाई कहाँ से आ रहा है? सप्लाई आ रहा है सेकेंडरी डिस्ट्रीब्यूशन ट्रांसफार्मर से, और उसको किस फॉर्मेशन में कनेक्ट किया गया है? इफ़ यू कैन वॉच इट प्रॉपर्ली, इट इज़ कनेक्टेड इन द स्टार फॉर्मेशन. ओके, और स्टार फॉर्मेशन के तीनों ही जो आउटर साइड्स है वहाँ से आपको तीन फेज मिल रहे हैं, आर, वाई एंड बी. सी, आर, वाई एंड बी, आपको स्टार फॉर्मेशन के तीनों साइड से आपको तीन फेज मिल रहा है, और सेंटर में से आपका जो न्यूट्रल है वो जा रहा है. ओके, और आपको दिख रहा है कि ये थ्री फेज आर, वाई एंड बी, आर, वाई एंड बी, एंड फोर वायर आर, वाई, बी एंड न्यूट्रल, फोर वायर सिस्टम. ओके, and why are we using it on a large purpose? Because थ्री फेज फोर वायर सिस्टम को यूज़ करने में सबसे बड़ा एडवांटेज ये है कि इससे आप थ्री फेज भी एक्सट्रैक्ट कर सकते हो, और साथ साथ में आप सिंगल फेज भी एक्सट्रैक्ट कर सकते हो. जैसे आप यहाँ पे देख सकते हो, सी यहाँ पे आपको यहाँ पे इन्होंने क्या किया, थ्री फेज एक्सट्रैक्ट कर लिया. मतलब यहाँ पे आर एक्सट्रैक्ट किया, यहाँ से वाई एक्सट्रैक्ट किया और यहाँ से बी एक्सट्रैक्ट किया, तो ये जो आपका लोड हो गया दैट इज़ अ थ्री फेज लोड. एंड सिमिलरली इफ़ यू वांट टू यूज़ अ सिंगल फेज लोड, व्हाट वी विल डू, यहाँ से आपने आर ले लिया और यहाँ से आपने न्यूट्रल ले लिया. अगेन दूसरा जो लोड है उसमें क्या हुआ, सिंपल अगेन यहाँ से उन्होंने वाई फेज ले लिया और यहाँ से न्यूट्रल ले लिया. तीसरा है वहाँ पे क्या हुआ, यहाँ से बी फेज लिया और यहाँ से न्यूट्रल ले लिया. ओके, सो सिंगल फेज भी आप यूज़ कर सकते हो, थ्री फेज भी यूज़ कर सकते हो, बट वाइल यूजिंग सिंगल फेज ऑलवेज रिमेंबर दैट one of the connections, one of the tappings that you are taking from the three phase systems should be phase and another one should be always neutral. Okay, दोनों ही phase जो होते हैं उनको we never use together in single phase system, huh? We never use it together. Okay, so these things we always consider while taking single phase tapping out of three phase connection. Okay, so uh, ये हो गया. एंड एक्सेप्ट फॉर दैट that whenever you are getting the tappings from this from your three phase connection, three phase जो थ्री फेज फोर वायर सिस्टम जो आपका आ रहा है वहाँ से, सो यू ऑलवेज कंसिडर वन थिंग, यू ऑलवेज टेक केयर ऑफ वन थिंग कि जो डिस्ट्रीब्यूशन जो होना चाहिए लोड का, ठीक है, लोड डिस्ट्रीब्यूशन जो होना चाहिए वो तीनों ही फेज में हमेशा इक्वल रहना चाहिए, जिससे फेज अनबैलेंसिंग जो होता है विच वी विल बी सीइंग इन द फर्दर लेक्चर्स, दैट डज नॉट टेक प्लेस. अगर ऐसा कर रहे हो कि आपने सारे जितने, जैसे कि आपके चार लोड है, समझो मान लो कि आपके चार लोड है और चारों ही लोड में आप क्या कर रहे हो, फर्स्ट वन इज़ वेरी हैवी, ओके, सेकंड वन इज़ वेरी स्मॉल, थर्ड वन इज़ स्मॉल एंड फोर्थ वन इज़ मीडियम. ओके, तो आपने ऐसा कर लिया कि जो सबसे हैवी लोड था वो और जो मीडियम लोड था वो दोनों ही सेम फेज से ले लिए, एंड देन बाकी के जो दोनों थे वो आपने किसी दूसरे फेजेस में डिस्ट्रीब्यूट कर दिए. सो दैट कॉजेज द अनबैलेंसिंग ऑफ लोड. ओके, सो रादर देन गोइंग फॉर दैट व्हाट वी विल डू, we will try to distribute the load uniformly. Okay, so this thing we should be always aware of. We should take care of this little things while distributing the load. Okay, now you might ask ki sir what will be the सिंगल फेज लोड एंड थ्री फेज लोड. तो सिंगल फेज लोड जो होते हैं वो जो हमारे जो रेगुलर डोमेस्टिक यूजेस में जितने भी आप अप्लायंसेस देखोगे दैट विल बी योर सिंगल फेज लोड, राइट. जो भी आप लाइटिंग लोड बोल लो या फिर फैंस दैट वी यूज़, मिक्सर्स बोल लो, टीवी जो हम यूज़ करते हैं, आयन बोल लो, जितने भी ज़्यादा कोई भी आप जितने भी अप्लायंसेस है, आप ओवन बोल लो, फ़ोन का चार्जर, दिस दैट एनीथिंग. ओके, मोस्ट ऑफ देम आर सिंगल फेज. और थ्री फेज में कैसे कौन से लोड होते हैं, तो लोड विच हैव रिक्वायरमेंट ऑफ हैवी पावर. जैसे कि आप देखो थ्री फेज सप्लाई में आप किसको कनेक्ट करते हो, अगर आप अपार्टमेंट में रहते हो तो देयर इज़ अ पंपिंग मोटर, ओके, टू पंप द वाटर on a higher grounds. So in that motor we use three phase load. So this was all about the single phase circuit and basic overview. Now let's come to some circuit elements. I'm pretty sure if you are in fifth semester or sixth semester of electrical engineering you might know these components: resistance, inductance, capacitance. Okay, and they all three have their various nature and they behave according to that. You can see the symbols of all three over here. This one is resistor, this one is inductor, here is the capacitor. Okay, what happens in resistive circuit, that whenever your load does not have any inductive or capacitive component in it, which means your load, whenever your load consists only resistive element, at that time the voltage and current will always be in the same phase. Always remember, they will be in the same phase if your circuit does not consist any inductive or capacitive element. Okay, so here you can see voltage and current are in the same phase. If your circuit consists only of okay, I'm putting pressure on only of inductive element, then your current will lag from your voltage at 90 degrees. And similarly, if you are having only capacitive element, then your current will lead your voltage at 90 degree. Okay, so uh, these are the uh, all three different natures of this circuit elements: inductance, resistance, and capacitance. Except for that, there is a term called power factor. What is power factor? Power factor is nothing but the difference between the voltage vector and current vector, or in other words, the phase angle between the waveforms of voltage and current. Okay, so uh, can you guess what will be the power factor and resistive element? The circuit consisting only resistive element, voltage and current both are in phase. Okay, so there is no angular difference between them two. Okay, so not only angular difference, I mean cos phi of angular difference. Okay, so there is no difference, so power factor is 0. Okay, again coming here 90 degree, again here 90 degree. So power factor angle for this one is 90, this one is also 90. Okay, right now we are only discussing about power factor angle. Power factor we will be discussing in upcoming lectures in detail, after discussing apparent power, reactive power, and active power. Okay, so right now we are only discussing about power factor angle, not power factor in detail. Okay, which is cosine of that angle. So that would be the angle. Now talking about the composite circuits, the circuits which include both resistive and either inductive or capacitive elements. What will happen with them? If your circuit is consisting uh, resistive plus inductive element, then the current of your circuit will lag the voltage at a certain angle. Let's call that angle of phi. Okay, so how will we draw that component? Let me show you how will we draw that component. First we will take first we will take voltage component. Here, this is your voltage component. This will be your current component. Okay, here, and this angle, see, this angle will be phi. We will call this angle phi. This is your voltage, this will be your current. Okay, similarly, can you guess if my composite circuit consists of R and C, means resistive and capacitive load, Then how will the phasor diagram will look like? Let's try to draw it. It will be very simple, right? It will be leading. It will be leading just like this. So this angle will be your phi. This will be your voltage. This will be your current. So this will be RC circuit. Then there is something called RLC circuit, which consists of both inductive and both resistive capacitive plus sorry both inductive capacitive plus resistive element, in which what will happen, the more dominant component among L and C, which means among inductor and capacitor, will be the deciding factor that if your current will lead the voltage or lag the voltage. But in most of the applications, in general, when we are using most of the loads are RL loads, means in them inductive component is always dominant, and because of that current is mostly lagging your voltage. So in most of the cases you will see that, what which image you will see, the second one, the one in the lower place. Okay, so that was about our circuit elements. Now let's come to the power in the single phase circuit. Okay, so coming to the power in the single phase circuit, you can see a circuit on the left. It consists of an AC source and a load connected with it. Okay, एंड ऑलवेज रिमेंबर, जो भी जनरेशन होता है, ट्रांसमिशन होता है, डिस्ट्रीब्यूशन होता है, दैट इज ऑलवेज डन विथ थ्री फेज सिस्टम ओनली. ओके, सिंगल फेज सप्लाई विल only be used in the domestic load operations. So here we are using single phase. We are using the power source VT, we are calling it VT, and the equation for VT is Vm sine omega t. Okay, whenever you are defining the power source and you are defining the components of power source, always remember there are three components. First one is magnitude or amplitude, which is Vm in our case. Okay, second one, frequency, which we have seen, sine omega t. Okay, and then third one is phase angle. If I'm not mentioning the phase angle, which means it is starting from zero. Okay, it is starting from zero, there is no lag or lead in the phase angle. Okay, so as you can see here, this one is the voltage, and it is starting from zero going here. And as I've said, as it is inductive circuit, inductive component is more dominant. Okay, so as inductive component is more dominant, then you can see here the current is actually lagging the voltage waveform is already been started from zero, but current waveform is starting a little after the voltage waveform has started. So current waveform is lagging from voltage waveform. Okay, now this Vm is the maximum voltage, sine omega t your frequency, and there is no phase lag. Okay, and what will happen with this circuit? uh, basically we are coming to the power in the single phase circuit. So we the goal of this whole simulation, whole calculation thing is to calculate the power of this circuit. Okay, now this phase difference, that I is lagging from V at phi angle, let's call this angle phi. Okay, and we have already assumed that the circuit is RL load circuit because current is lagging from voltage. Okay, so uh, considering general principle, what will be the power of this circuit? Power is nothing but multiplication of voltage into current, so power will be V into T. Okay, V, we have defined that what will be V. V will be Vm into sine omega t, right? And based on that, based on this waveform, can we define I? Based on this waveform, we can say I is Im sine omega t, right? You can see the amplitude of I is not as similar as V, so we are calling it Im. Okay, it is making a sine wave, as you can see, and the frequency is similar to the voltage, which is pretty much clear here. You can see it is starting from here, coming here, it is starting from a little theta phi angle after it, and the first cycle is ending exact same point, like exact phi distance, and the last cycle is also ending at the exact phi distance here. So the frequency is also same, so it will be Im sine omega t, but my current waveform is starting a little late, which means it is lagging by which angle? Angle phi. So the current waveform will be Im sine omega t minus phi. Okay, now putting the value of Vt and It into the first equation of Pt, so Pt will be Vm sine omega t into Im sine omega t minus phi. Okay, then keeping Vm sine omega t as it is, and uh, with this sine omega t minus phi, what we will do, we will implement the equation of sine a minus b. Okay, what is the value of sine a minus b? It is sine a cos b minus sine b cos a. Okay, always remember sine a minus b is sine a cos b minus sine b cos a. So we have elaborated it over here. Then what did we do? We multiplied this sine omega t, with the with we took this sine omega t into the bracket. So what will be our equation? Vm Im sine square omega t into cos phi minus sine omega t into cos omega t into sine phi. Now we can convert this maximum value into RMS value, root means square values, which you might have studied in the fourth or third semester, that when we convert this maximum value into root mean square value, what we will get? We will get VRMS will be equal to Vm divided by root 2, and same value will be for Im. So Vm by root 2 into Im by root 2, and multiplied by the same equation. Okay, the same equation which we were using, because we want to convert this equation into VRMS. We need to get under root 2 under both of my entities Vm and Im, so we are multiplying and dividing by 2. So the 2 which we have multiplied with goes into the bracket, and 2 which we have divided with will be cut half into 2 root 2's, and first root 2 will be below Vm, another root 2 will be below Im. Now converting it, what we will get? We will get VRMS into IRMS. VRMS into IRMS came from where? Here. Vm by root 2 equal to VRMS. Im by root 2 will be equal to IRMS. Okay. Then what we have done? Interesting thing. Something interesting. Okay. If you remember, what is the value of cos 2 theta. Okay, what will be value of cos 2 theta? It is always 1 minus 2 sine square theta, right? Cos 2 theta is always equal to 1 minus 2 sine square theta. So this 2 sine square theta, if you make 2 sine square theta the subject, we will get 1 minus cos 2 theta, right? So except for 2 sine square omega t, we have written 1 minus cos 2 omega t based on that formula, and we are writing cos phi as it is. And about this 2 sine omega t into cos omega t, okay, 2 sine omega t into cos omega t, we are writing it sine 2 omega t, which is nothing but the formula of sine 2 theta. Sine 2 theta is equal to 2 sine theta into cos theta. Okay, sine 2 theta is always equal to 2 sine theta into cos theta. So we are writing it here, and except for that remaining things are as it is. Sine phi comes here as it is. This thing which we have multiplied inside, Vm by root 2 is Vrms, Im by root 2 is equal to Irms, and we have multiplied both of them inside the bracket. So uh, Vrms, Irms, sine phi into sine 2 omega t. And where did this 2 go? It is part of the formula. Sine 2 omega t is equal to 2 into sine omega t into cos omega t, right? So uh, we are getting the part of, we are getting the power of single phase circuit. You can give the power of single phase circuit based on this equation. Now if you notice something interesting that we have done, that the whole part before this minus, we have considered only cosine part. You can see here we have only cos, Vm Vrms into Irms, cos phi into 1 minus cos 2 omega t, and then after that we have only sine part, Vrms, Irms, sine phi, then sine 2 omega t, right? So this cos part, this cosine part, and by I mean cosine part, I mean not the whole part, only this part, Vrms into Irms into cos phi. Let's call it P. And the sine part, I mean Vrms into Irms into sine phi, call it Q. Then my formula Pt will be P into 1 minus cos 2 omega t minus Q into sine 2 omega t. Okay, and this cosine part is called active power, and the other one, the sine part, is called the reactive power. Okay, and the addition of both of this power is called apparent power or real power. On the right hand side here you can see the waveform of the active power component. Okay, uh, what will happen, even though active power is just product of V and I, the value is positive, but frequency of this wave will be twice than the supply frequency. Okay, supply frequency, if you remember, we are getting only p, and but here we are getting double, we are getting 2p, vi into um, v of t into I of t. If you have studied signal and systems in that course, uh, we learn about how the addition of signals takes place, right? So based on that, we will be getting this. uh, After that, let's come to calculating the apparent power. If I want to calculate the uh, magnitude of apparent power, then it will be nothing but s will be under root of p square plus q square, which means p square plus q square will be s square. So coming towards that, okay, coming towards that, p square plus q square, here what we have done, we have just elaborated the whole equation which we have considered. Like we have considered p is equal to vrms irms into cos phi, q equal to vrms irms into sin phi. So we just elaborated it. Sin square plus cos square is always 1, so we will be left with only vrms into irms whole square, and that will be pretty much the value of S square, which is VRMS into IRMS whole square. So now, based on that, what we can see, S is nothing but the multiplication of uh, RMS voltage with RMS current. Okay, apparent power is nothing but the multiplication of RMS voltage with RMS current. If you want to write it in the complex form, you can write P S equal to P plus QJ or P plus JQ. Okay, that is the complex form of my apparent power, where P is again same cosine component, Q is again sine component. Okay, and as we know that cosine is an even function. If you have seen that cosine is an even function, and because of that, what will happen whenever real power component whenever real power component has given negative value, it will still return the positive value. Okay, but it will not be the same case with apparent power. Sorry, not apparent power, apologies. It will not be the same case with reactive power. Okay, because it is the function of sine component, and sine component is odd function. So if you give it a negative power, then sorry, if you give it negative, then it will a negative signal, it will return negative. If we give positive, it will return positive. Okay, so the waveform of the reactive power, it is sinusoidal, right? But it is positive in both quadrants, positive and negative quadrants. Okay, then there is one more interesting thing about reactive power, that it keeps shuffling back and forth, it travels from source to load, and it also returns back from load to source. Okay, which is not the same thing for active power. Active power generally, what it does, it travels from source, and and that gets delivered at load. Okay, and load consumes its power, so that is active power. Okay, so about active reactive apparent power we'll be discussing in detail in the next lecture, when we will see the power triangle and the reactive power balance phenomena in detail. Till now we're keeping the first lecture till here. I hope you guys uh, liking the lectures. If you have any doubts or queries, you can mention in the comment section below. I will try to answer as many as doubts possible, and I will be seeing you in the next lecture. Bye bye. Thank you.